Hi, this video is going to show you how to do a two-mean test in SPSS. This is a very simple, straightforward version, very abbreviated. There are a lot of things you can do in SPSS when comparing means. But we're going to show you how to do the kind of stuff we've been doing in the assignments and in the modules in SPSS, and it's going to help you get your assignment done. So first is bring up the GSS 2014 dataset. I have it open here. We're going to go to Analyze. Then we're going to go down here just a few clicks to compare means. Now there are a lot of different ways to compare means, as I said, and you may be a little bit lost here. You want the independent samples t-test. That's going to give you the kind of thing we've been doing. Click on that. And what you have here is a test variable and a grouping variable. The grouping variable is going to be your nominal variable, because your nominal variable has the groups you want to compare: male, female, or black, white, if your variable is race, or year in school, freshman, sophomore, junior. So this part's just a little tricky. You just have to come over here. So highlight the variable you're interested in, click the arrow to fill it over, and you're going to get these question marks. So in order to fill those out, you're going to have to put group 1 and group 2, and you're going to have to put the value that goes with the group. So if you come over here to your variable view in the data set, click on variable view right here, come down and find the variable that you're interested in. So in this case, we're interested in sex, but it might be race or whatever else. And when you find that variable, you're going to come over here to the values, this values column. Click on these three little dots. If you hover over this blue box with the three little dots will appear. Click on that, and it's going to tell you 1 is male and 2 is female. So here, those are the groups I want. You may have more groups, 1 through 7, and you may want to compare 3 and 6. That's fine too. Just write down and remember the groups that you're interested in. Swing back over here, put in 1. In this case, group 1 will be male, group 2 will be female, and I hit continue. And now if you come under options, this is where you can set your confidence interval. So if you have a 5% alpha level, you want a 95% confidence interval. If you have a 10% alpha level, 0.1, then you're going to have a 90% confidence interval. And here we're just worrying about two-tailed tests. We're not going to worry about anything else. So everything here is two-tailed. So now you need your test variable, which is going to be your interval or ratio level variable. Here I've chosen years job. It's how long the respondents spend at their current job. So you can click on that and then click the arrow to bring it over again and hit OK. Then you get your outputs. Come up here, and what you have, you can see the number for each: 608 males, 633 females, and you can see the mean for each. So men on average have been in their jobs 8.8 years, and women have been in their jobs 8.0 years in their current job. So you can see that men have been in their current job longer than women, but the question is if it's statistically significant. Did that difference just happen by chance? This was the kind of sample we got, or is there really a difference? So you've been using this equation to compute standard error, and it's standard deviation of men squared divided by the number of men in the sample. So you can see what you're really doing is 9.7 squared divided by 608. And then you do the same thing for women, 8.86 squared divided by 633. You add those two numbers together, take the square root, and you would see this. You would end up with the same numbers that we have here. You get the same standard error. The difference between male and female is right here, 0.797. So you could take this 0.797, divide by the standard error number that you compute, and you would come up with the same answers that you see here, that SPSS will produce. Now, you'll see here that there are two options: equal variance assumed and equal variance not assumed. And some of you have probably noticed in the book that there's this equal variance assumption calculation for standard error that's very complex. And what happens is that a lot of times in practice, it doesn't give you an answer that's all too different from the unequal variance equation, which is the one we've been doing, s squared divided by n plus s squared of the second divided by n of the second root. Add them together, take the square root. I don't have you do both by hand because I find that it is worthwhile because they are different answers, and it is proper to use the equal variance assumption equation if these standard deviations are very close. And if they're not, you should use equal variance, not assume. So it can make a difference. I don't have you use both equations to compute by hand because I find that it adds more confusion than the value that it adds. So the main point is for you to get the idea of what you're doing here when you're computing the difference between means, a difference in means test. And here in SPSS, now you should recognize that. So you have these two options, and as you can see, the result's not that different. This sig two-tailed is the p-value. So if we assume equal variance, we have a p-value of 0.131. If we assume unequal variance, we have a p-value of 0.132. So you can see it wouldn't make a difference in our conclusion. But if you want to know which one you should technically use, you look at this Levene's test. And this has a hypothesis, much like what we've been doing. So it's like a hypothesis test within a hypothesis test. And the assumption is equal variance. So HO is equal variance. Here, the p-value, the significance of this Levene's test, is higher than 0.05. So we fail to reject this null hypothesis. So really, technically, these differences in variance are not extreme enough to say that they're different. So we fail to reject the null hypothesis of equal variance. We assume that there is equal variance here, and they're pretty close. But it's borderline. Now, as you can see, it doesn't. At the end of the day, it wouldn't make a difference in our conclusion. Our p-value is 0.13, and if we have an alpha level of 0.05, then we reject our null hypothesis that men and women have been at their current job the same amount of time. Men and women spend the same amount of time at their current job. If we're lower than 0.05, we'll reject that hypothesis. Here, we're larger than 0.05, so we fail to reject. We cannot reject this hypothesis that they are equal. So that's our conclusion, and you could go back and get a bigger sample and maybe see if it's significant when you have a little bit bigger sample. A lot of people don't answer the time and job question. As you can see, we only have 1,200 respondents, so it's not even half. So you could try to get a little bigger sample and see what's going on. But that is the test in a nutshell, and how you compute it. So the key here is that this will give you your mean for each group. This is your difference, and this is what you're really interested in, is the significance, the p-value. And if that's greater than 0.05, you will fail to reject your null hypothesis. If that's lower than 0.05, you'll reject your null hypothesis that these are equal. So hopefully that helps out, and I'll see you next time.